Yo, bro, do you know that song that goes like, I see the crystal raindrops fall, and the beauty of it all is when the sun comes shining through.
To make those rainbows in my mind when I think of you sometime, and I want to spend some.
In the realm of military aviation, the development of the AH-64 Apache helicopter marks a significant chapter in the evolution of combat aircraft. The AH-64, originally known as the Hughes AH-64, emerged as a result of the U.S. Army Advanced Attack Helicopter AAH competition held between 1973 and 1976. This competition aimed to produce an advanced attack helicopter capable of conducting anti-armor operations in diverse conditions, including day, night, and adverse weather scenarios. An important focus was the helicopter's ability to operate in tandem with troops on the battlefield, reflecting the evolving strategic thinking based on combat experiences in Vietnam. The decision to develop the AH-64 Apache was influenced by several factors. The cancellation of the AH-56 Cheyenne project in 1972 played a pivotal role, as the U.S. Army redirected its focus towards producing an aircraft tailored for anti-armor missions. Unlike the AH-1 Cobra, the Army desired a helicopter that could surpass the Cobra's capabilities in terms of firepower, performance, and range. Additionally, strategic considerations stemming from the 1948 Key West Accords played a role, as these agreements prevented the Army from possessing fixed-wing combat aircraft. To fulfill this requirement, the U.S. Army issued a request for proposals for the AAH program on November 15, 1972. Subsequently, Bell, Boeing, Grumman, Hughes, Lockheed, and Sikorsky submitted proposals. After a rigorous evaluation process, Bell and Hughes helicopters were chosen as finalists in July 1973, marking the beginning of Phase 1 of the contest. This phase involved the development and flight testing of helicopter prototypes. Hughes' AH-64A prototype first took to the skies on September 30, 1975, while Bell's AH-63A prototype followed suit on October 1, 1975. The outcome of this evaluation favored the Hughes design, leading to the Army's selection of the Hughes AH-64 on December 10, 1976. The next phase involved Hughes being awarded a contract to initiate a comprehensive full-scale engineering development program commencing in 1977. The decision was influenced by factors such as the more damage-resistant four-blade main rotor of the AH-64A and concerns about the unstable three-wheel landing gear arrangement of the AH-63. This marked the transition of the AH-64A into Phase 2 of the AH program. During Phase 2, the AH-64A underwent significant enhancements, with the integration and testing of various weapons and sensor systems, including the laser-guided AGM-114 Hellfire missile. The development of the Hellfire missile began in 1974, with the aim of providing helicopters with a highly effective anti-tank missile. The original design of the AH-64 featured a T-tail configuration with the tail rotor positioned midway on the vertical stabilizer. However, as the development progressed into Phase 2, the tail design underwent a significant transformation. The T-tail was replaced with a low-set, fully movable horizontal stabilizer and a high-mounted tail rotor, which became integral features of the production AH-64 Apache. The journey of the AH-64 Apache continued with successful operational tests in 1981, following which improvements were made, including upgrading to the more powerful T700 GE701 engine. The AH-64 was formally named the Apache in late 1981, adhering to the tradition of naming Army helicopters after Native American tribes. Full-scale production approval was granted in 1982, and in 1983, the first production Apache helicopter rolled out at the Hughes Helicopters facility in Mesa, Arizona. The AH-64 Apache is a formidable multi-mission attack helicopter known for its stability, survivability, and lethal capabilities. Designed with a tandem-seated crew configuration, the Apache features a four-blade main rotor and a four-blade tail rotor. The crew arrangement places the pilot above and behind the co-pilot/gunner, with both crew members capable of independently piloting the helicopter and engaging targets. Powering the Apache are two General Electric gas turbine engines rated at 1,890 shaft horsepower, each equipped with high exhausts on the fuselage sides. Notably, different engine models are used, with Rolls-Royce engines utilized by personnel in the UK. An upgraded T700 GE701D engine, producing 2,000 shaft horsepower, was introduced in 2004 for the AH-64D variant. The helicopter's maximum gross weight of 17,650 pounds supports a cruise airspeed of 145 miles per hour and a flight endurance of over 3 hours. For extended range, the AH-64 can be equipped with external 230-gallon fuel tanks. The design of the Apache prioritizes crew protection and survivability. The crew compartment and rotor blades are engineered to withstand a 23mm bullet impact. The airframe boasts around 2,500 pounds of protection and incorporates a self-sealing fuel system to safeguard against ballistic threats. The cockpit and gunner's seat are separated by a transparent blast shield designed to ensure the survival of at least one crew member in the event of a direct hit. The airframe adheres to the crash safety requirement, which mandate energy attenuation measures to minimize crew injuries during impact. The Bell AH-64D/E Apache can achieve a maximum speed of approximately 284 km per hour, 176 miles per hour, at sea level. Its cruise speed is around 227 km per hour, 141 miles per hour, ensuring efficient and controlled flight. The Apache's exceptional maneuverability allows it to operate at altitudes of up to 21,000 feet, 6,400 meters above sea level. The helicopter's climb rate is an impressive 889 meters per minute. The AH-64 Apache boasts a ferry range of 1,900 kilometers. The helicopter's weight is approximately 5,165 kilograms, while its maximum takeoff weight reaches 10,433 kilograms. The main rotor system of the AH-64 consists of 4 fully articulated rotor blades, allowing them to respond to aerodynamic forces and pilot inputs. The unique design of the tail rotor, with 2 sets of blades mounted at a 55 degrees angle, enhances efficiency and performance, enabling simultaneous flapping and feathering motion. Continuing the trajectory of its development, the AH-64 Apache underwent significant advancements and upgrades that further enhanced its capabilities. In the 1980s, McDonnell Douglas embarked on a study for the AH-64B, envisioning a modernized cockpit, an upgraded fire control system, and other enhancements. However, by 1988, the scope expanded into a broader multi-stage upgrade program aimed at improving sensors and weapon systems. As technological advancements unfolded, the project's ambitions grew, ultimately leading to the discontinuation of the program. A pivotal turn occurred in August 1990 when the Defense Acquisition Commission granted approval for the development of the AH-64D Apache Longbow. The maiden flight of the first AH-64D prototype took place on April 15, 1992, followed by extensive testing that concluded in April 1995. During testing, a comparison between 6 AH-64D helicopters and a larger group of AH-64 has revealed that the AH-64D exhibited a remarkable 7-fold increase in survival capability and a 4-fold increase in lethality when compared to the AH-64A. Following successful testing, full-scale production for the AH-64D was sanctioned on October 13, 1995. This marked the beginning of a new phase in the Apache's evolution. In August 1996, a significant contract worth $1.9 billion over 5 years was signed for the upgrading of 232 AH-64 as to the AH-64D configuration. The production of AH-64D helicopters commenced, with the first production AH-64D taking its inaugural flight on March 17, 1997, and being delivered on March 31. As the AH-64A's support was phased out starting in 2008, efforts were made to encourage countries operating older Apaches to undertake modernization programs. The Apache's array of sensors and onboard avionics empowers it to operate effectively in varying conditions. These systems encompass target acquisition and designation capabilities, the pilot night vision sensor, passive infrared countermeasures, GPS, and AHATS. Equipped with a longbow radar, the Apache can detect up to 256 targets simultaneously within a 50 kilometers, 31-mile radius. In August 2012, 24 U.S. Army AH-64DS were outfitted with the Ground Fire Acquisition System, which detects and targets ground weapon fire sources across a 120-degree field of view and all lighting conditions. The system employs sensor pods and a thermal imaging camera to pinpoint muzzle flash locations. Lockheed Martin has played a pivotal role in enhancing the targeting and night vision systems for the Apache. The Arrowhead system, utilizing second-generation long-wave infrared sensors, offers improved range and resolution. It features a targeting FLIR with 3 fields of view, a dual field of view pilotage FLIR, a CCD TV camera, electronic zoom, target tracking, and auto bore sight capabilities. Countermeasures are integral to Apache's defensive capabilities. It is equipped with an electronic warfare suite featuring radar warning receivers, radar frequency interferometer electronic support systems, infrared countermeasures, laser warning receivers, radar jammers, and chaff dispensers. Diverse forward avionics bays mounted on either side of the fuselage house key avionic components. The air data sensor system provides vital air temperature, wind speed, and wind direction data to the fire control computer for accurate ballistic solutions, aiding in firing corrections for the 30mm cannon and rockets. In terms of armament configurations, the AH-64 can be adapted for different roles within the context of close combat attack. Alongside the 30mm M230E1 chain gun, the Apache can carry external storage and weaponry on stub wing pylons. Common armament includes AGM-114 Hellfire missiles and Hydra 70 general-purpose unguided 70mm rockets. The Hellfire missile can be equipped with thermobaric warheads for use against ground forces and urban warfare. The Hellfire missile is the cornerstone of the AH-64 Apache's armament. This laser-guided anti-tank missile possesses the capability to destroy armored and hardened targets at distances of up to 8 kilometers. It can receive guidance from a ground laser designator or an airborne laser, such as those carried by an OH-58D or the AH-64 itself. The Apache typically carries a complete complement of 16 Hellfire missiles, with 8 mounted on each wing. These missiles are stored under protective nose glass domes. The Apache is armed with a 30mm automatic Boeing M230 chain gun located under the fuselage. This area fire weapon is designed to suppress targets at close ranges, up to 4 kilometers. Capable of firing high-explosive dual-purpose ammunition, the gun achieves a rapid rate of fire of 625 rounds per minute. Its magazine, situated in the belly of the aircraft, can accommodate a maximum of 1,200 rounds. The gun's movement range includes azimuth adjustments of up to 86 degrees left and right, as well as elevation and depression of 30 and 60 degrees, respectively. It can be aimed by the co-pilot gunner using TADS day or night sensors, or by either pilot using the AHAD's helmet-mounted sight. The Apache employs 2.75-inch folding fin aerial rockets, also known as Hydra 70 rockets. These rockets serve as an area target weapon system, suppressing enemies and destroying light-skinned vehicles and other soft targets at ranges of up to 7.5 kilometers. They can be fired in various quantities, including singles, pairs, or multiples of 4, 8, 12, and all. These rockets carry diverse warheads, including high-explosive, smoke, and multi-purpose submunition variants. MPSM warheads release 9 high-explosive dual-purpose bomblets that target the area, capable of penetrating light armor and causing fragmentary explosions. Each rocket pod can hold 19 rockets, and typically, an Apache carries 2 rocket pods for a total of 38 rockets. While current U.S. Army units do not employ Stinger air-to-air missiles on the Apache, provisions exist for mounting them on the wingtips with minor modifications. The Stinger is a compact infrared anti-aircraft missile, often used as a shoulder-launched man-portable system. Additionally, external fuel tanks can be mounted on the stub wings to extend range and mission time. The AH-64E model has the capability to control unmanned aerial vehicles for aerial reconnaissance, offering enhanced situational awareness and support. There are possibilities for further developments in armament capabilities. Boeing has explored the concept of outfitting the AH-64 with directed energy weapons, potentially enabling the destruction of enemy communications and equipment. In collaboration with Raytheon, the Army successfully demonstrated a high-energy laser system on the AH-64. The Apache has also been tested with the MBDA Brimstone anti-armor missile, and the U.S. Army has announced plans to field Spike NLOS missiles on the AH-64E Apache for enhanced ammunition capabilities. The AH-64D/E Apache has carved out an illustrious and enduring operational history, leaving an indelible mark on the United States military and numerous countries worldwide. Its journey is marked by pivotal milestones and missions that underscore its exceptional effectiveness and adaptability. The Apache's baptism by fire occurred during the Gulf War in 1991, where it emerged as a formidable force. Its remarkable capacity to neutralize enemy tanks, vehicles, and diverse targets positioned it as a game-changer on the battlefield. Their impressive performance included the destruction of over 500 enemy tanks, armored personnel carriers, trucks, and other vehicles, all while maintaining readiness rates of over 85%. Throughout the tumultuous Balkans conflicts in the 1990s, the Apache's resounding impact was evident. Serving as a steadfast provider of close air support to ground troops and executing crucial reconnaissance missions, it solidified its role as a force multiplier. The AH-64 Apache's legacy further evolved during the extensive campaigns in Afghanistan and Iraq. Its vital contributions range from offering steadfast fire support to ground forces to executing meticulous reconnaissance and surveillance operations. Targeting enemy positions and infrastructure, the Apache played a pivotal role in shaping the course of these conflicts. Beyond its combat roles, the Apache exhibited remarkable versatility. It engaged in diverse operations, spanning peacekeeping missions, disaster relief efforts, and counter-terrorism endeavors. This adaptability underscored the helicopter's multifaceted utility on the global stage. As the years unfolded, the AH-64 Apache has undergone continuous enhancements and upgrades, a testament to its enduring significance. The AH-64E Apache Guardian, among newer variants, epitomizes this evolution, boasting advanced avionics and weapon systems that amplify its potency on modern battlefields.